All right, so now that you copied down the notes on quantum numbers, what each of the quantum numbers are, I'm going to go through the notes examples with you. This is mainly for those of you that were not in class today, or if you just want to review back over the last 4 examples that I worked through with you. All right, so after we went through the notes today, we looked at our periodic table and we talked about how to find your N and your L quantum number pretty easily by looking at your periods, and also we talked about the S block, the P block, the D block, and the F block. So let me just remind you that the N quantum number is your quantum number that tells you the period or the energy level of the electron. So it is corresponding to the periods. So for the S block, which are your alkali and alkaline earth metals, and for the P block, which are over here, your groups 3A to 8A, then the periods are numbered 1 to 7 here and then 2 to 7 here. Remember, for all our purposes of quantum theory as well as electron configuration, we want to consider helium as if he were right beside of hydrogen over here. He's in the S block, okay? All right, so 1 to 7. Now, when you get to the D block, where your transition metals are, these are off by 1. And if you go back to the quantum theory and work it all out, you will find that the D orbitals begin in the 3rd energy level. So the D block, which starts here at scandium, these are numbered 3, 4, 5, and 6 for your periods. And also the F block, which are your lanthanides and actinides, they're numbered 4 and 5. If you look back at where they actually fit into the table, 58 is the atomic number here, so it would go between 57 and 72. So if you look, this is where it would fit. Well, it looks like it starts in the 6th energy level or the 6th period, but the F block is off by 2 from what they appear to be. So the F block periods are 4 and 5. Okay, now that's your N quantum number. The L quantum numbers are 0 for the S, L for all the P's, 1 for all the P's, 2 for all the D's, and L is 3 for all of the F's. Now, we're going to be finding NLM and S. I will, as I go through the 4 examples in the notes, I will be talking about finding M and S and how you find them at the same time. Okay, so the first example in the notes, I'm just going to look back. This is the slide in your notes that you have. We're doing magnesium for our first example, then we're going to do iron, selenium, and uranium. Now remember, we're finding 4 quantum numbers. N is your principal quantum number, and it corresponds to the period on the periodic table. L is your orbital quantum number. It tells you the shape of the orbital. M is called the magnetic quantum number. I call it the mailbox number. And if you go back to the lesson that I posted, you will hear why I call it the mailbox number. And then S is your spin quantum number. It tells you the direction of spin of the electron, and it's either going to be a positive 1/2 or a negative 1/2, representing a clockwise rotation or a counterclockwise rotation. There's only 2 directions the electron can spin. So let's look at magnesium. So find the element on the periodic table, magnesium, and N is your energy level. So notice he's in the 3rd energy level, so N is 3, and he's in the S block. That means L is 0. So we'll go ahead and fill those 2 in. N is 3 because that's his period, and L is 0 because he's an S orbital, and the L quantum number for all of the S's are always going to be 0. Now, for the mailbox number, so we talked about how many orientations in space. That's what this represents, the number of orientations in space. So we talked about drawing the boxes or the orbital notation, and then you number your boxes. Remember, the values for M depend on L, so they can go from negative L to positive L. And you have to draw your boxes, number your boxes, then fill in your electrons. And when you do that, you will be finding M and S simultaneously. So I'm going to draw my boxes over here. Okay. All right, so for the S block. We said there was one orientation in space. That means we draw them in one box. Now, you're going to number that box. Since the boxes are numbered from negative L to positive L, that's the stipulation for M, L is 0. So there is no such thing as a negative or positive 0. That means you just have only one box and its number is a 0. All right, now you're going to put your electrons in. Now, when you're putting your electrons in your boxes, you go to the block that the element is in that you're looking at. In this case, we're looking at magnesium, so you just focus on the S block. And you're going to count as you go from left to right, count until you get to magnesium. Well, 1, 2. Again, start at sodium and you count till you get to magnesium. Make sure you're only looking at the block that the element is in, S, P, D, or F. Here we're S. 1, 2 is the second element. What that means is we're going to put 2 electrons in this box. Now remember, I gave you the analogy of the wives have to come home first, and all of my wives are spinning clockwise. Then the husbands get to come home last. They're spinning counterclockwise. We represent a clockwise spinning electron with an up arrow, so that represents sodium's electron. He's the first element in that row. And then we put magnesium. We said he was the second one over, so we're going to put 2 electrons in. So we go up, down. We always focus on the last electron that we put in. He's pointing down. That means his spin is counterclockwise, so you would say the spin is -1/2, and you do need to put the sign here. The mailbox number is 0. That represents the magnetic quantum number, which is the number of orientations in space, and the box number is 0. So 300, -1/2 would be your answer on that one. Let's look at the next example, iron. Okay, so find iron on the periodic table. Iron is here. He's in your transition metal family, which is your D block. All right, let's do our N quantum number first. Remember, N is your energy level. N for energy level. So find your energy level. Remember, the D's are off by 1, so the D's are numbered 3 here. Okay, so N is 3. He's a D orbital, so L is 2. Let's go ahead and fill those in. So we say 3 for the N, 2 for the L because he's a D orbital. Now we're going to draw our boxes. We said for the D's, you can draw 5 boxes. So you're going to come over here, you're going to draw your boxes and number your boxes. These are the 5 boxes for the D's. Okay. Now number your boxes. The numbers go from -L to +L. So L was 2. So I say -2, -1, 0, 1, 2. This is like a number line. 0 is always in the middle of our boxes. Now, let's go back and find iron again, and we're going to count till we get to iron. And when you do this part, you want to make sure you only focus at the D block. Okay, so I'm going to look not at the S's or the P's or the F's. I'm looking at the D's, and I'm going to count till I get to iron. So you start counting on scandium. 1, 2, 3, 4, 5, 6. He's the 6th one over. Now I'll count it again, starting with scandium. 1, 2, 3, 4, 5, 6. That means we have 6 electrons to place in our boxes. So go to your boxes, and let's put our electrons in. Remember, all the Y's have to come home first. So we have to fill up every box with an electron spinning clockwise. So 1, 2, 3, 4, 5. Now, how many electrons did we have to put in when we counted? That's right, we counted to 6. So we put in 5. So now we're going to come back, and now our counterclockwise can come in. These are what I call my husbands. So you focus on the last electron you placed in your box. So the last one we drew was the down arrow. That means this is spinning counterclockwise. Now his mailbox number is -2. His magnetic quantum number is -2. So 3, 2, -2, -1/2 gives us the address of iron's last electron. Let's look at selenium. Selenium is over here in the P block. You'll find selenium here. So with your energy level, remember, 1, 2, 3, 4. He's in the 4th energy level, or the 4th period. The P's are normal. Okay, so you're going to put 4. L is 1 because he's a P orbital. Draw your 3 boxes. -1, 0, 1, and you're going to count over. He is the 4th one over. Up, 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 down. So -1 and -1/2.